In this video, we're going to talk about applications of exponential and log functions. So the first thing we're going to talk about is when we see something that says it's compounding a certain number of times per year. So we have this formula where A is the ending amount, P is the starting amount or the principal, R is our rate as a decimal, T is the time in years, and N is the number of compoundings per year. So in example 1, we have how much money would be in an account after 11 years with a principal balance of $6,000 and an interest rate of 3.2%. If the interest is compounded monthly, quarterly, weekly, or semi-annually. So first off, we need to identify the information that we were given. So it says how much money would be in an account after 11 years. So our time for all of these examples is going to be 11. And it says our principal balance of $6,000, so that's our P. And then we have an interest rate of 3.2%. So we cannot use 3.2 because that is a percent. We need to make sure we change it to a decimal. So you would move it 2 places to the left, and then any open space you would add a 0. So in our equation, we're actually going to use 0.032. So from here, we can go to part A where it says monthly. If it's compounding monthly, that means that our N is going to be 12 because monthly, there's 12 months in a year. So all we're going to do now is plug this information into our formula. So we have $6,000 times 1 plus our rate, 0.032, divided by 12 to the power of 12 times 11. So we're going to type that information into our calculator to evaluate. So make sure you type it in exactly as it looks, and that your exponent is 12 times 11. So when we do that, when it's compounded monthly after 11 years, there should be about $8,527.46. And so that would be our answer for this problem. If we go to B, everything's going to be the same except N, and this time N is going to be 4 because it's quarterly. So our formula is exactly the same, except we're changing N to be 4. So we type that back into our calculator to see what we get. And when we change our our N to 4, it is $8,519.51. Okay, when we go to weekly, how many weeks are in a year? That would be 52. And so now I am going to change everything to 52 for N. So we have 6,000 times 1 plus 0.032, all divided by 52 to the 52 times 11 power. So we type it into our calculator, and we would get 8,530.53. So you do need to make sure that you're typing this into the calculator and you're getting the same numbers. And again, you're typing it in exactly as it looks. Part D says semi-annually, so that means that N is going to be 2. If it was just annually, then it would be 1. So we have 6,000 times 1 plus 0.032 divided by 2 to the 2 times 11 power. So we type it into our calculator and we get 8,507.71. So you get that. If n said annually, so just annually and not semi-annually, then n would equal 1. If it said daily, n would equal 365 days unless you were told a different day amount. Okay. So now looking at the next one, it is the formula that we use for when it is compounded continuously. So we have some of the same variables. So A is still our ending amount. P is our starting amount. E is a button on the calculator. So to get that, you'll put a second LN, which is next to the number 4. Our rate is still as a decimal, and T is our time. So how much money would be in an account after 11 years with a principal balance of $6,000, interest rate of 3.2%, and its interest is compounded continuously? So that's how we know to use this formula. So it's the same information as above. Our principal is $6,000. Our rate is 0.032, and our time is 11. So our formula would be A equals 6,000 e to the 0.032 times 11 power. So again, E is a button on the calculator that you would use. So I have 6,000, I'm typing it into the calculator. Second ln, my exponent is 0.032 times 11. And so after 11 years of it compounding continuously, I would have about $8,531.45 in the account. Okay. Now, on the back side, we have problems where we're not solving for A. We're going to end up solving for our time, just to practice our skills on solving equations with logs and exponential functions. So determine how many years it would take for a principal balance of $3,200 to triple if the interest rate is 3.2% and the interest is compounded monthly. So because it says compounded monthly, that means we're using the first formula. So the first formula was A equals P times 1 plus R divided by N to the RT power. So our A is what it's going to triple to, so that would be 3 times 3,200, which is equal to 9,600. Our P is that starting amount of 3,200. The rate is 0.032. Our N is monthly, so that would be 12. And our time, we don't know, so it's a question mark. So when I plug all this information in, we would get 9,600 equals 3,200 times 1 plus 0.032, all divided by 12 to the 12 T power. And that should be an N, not an R right there. So our T is in the exponent. So what we need to do is we need to get our base by itself, which is that 1 plus stuff. So I'm going to type in, I'm going to divide both sides by 3,200. When we do that, that should give us 3. And so it leaves me with that. And then I'm going to type this into the calculator. To get a decimal. So 1 plus 0.032 divided by 12. So we would get about 1.002667 to the 12t power. Okay, I'm at a point where there's nothing else I can do to solve except for switch it to logarithmic form. So currently we have n equals b to a p. So to switch it to log form, we're going to have log of our base, or log base b of a number equals the power. So when I do this, I get log, my base is that long decimal, and then my number is going to be 3, and it's going to be set equal to my power of 12t. Okay, before I type it into the calculator, I'm going to go ahead and divide both sides by 12. And so this right here is what I'm going to type into the calculator. So I'm going to hit alpha window 5. I'm going to type in that long decimal for my base. In the parentheses, I'm going to type 3. And then I'm going to divide it by 12. So I should have started with the fraction button. But when we do that, we get t equals 34.38. So it would take about 34.38 years for it to triple. If we needed to round to the nearest year, it'd probably be about either 34 to 35 years. Since that decimal's there, it's probably more 35 years if we're going to the nearest year for that. Example 4, determine how many years it would take for a principal balance of $5,000 to increase to $9,350 if the interest rate is 2.2% and the interest is continuously compounded. So continuously compounded is our key right there. That means we are using the A equals P times E to the RT power. So I am given A. That's what we want it to grow to. So that's that $9,350. P is that starting amount, which was that $5,000. E is a button on our calculator, and our rate was 2.2%. So if I move that decimal 2 places to the left, it's going to be 0.022%. So we plug in this information, $9,350 equals $5,000, e to the 0.022t power. So same concept, we want that base to be by itself, so we're going to divide both sides by 5,000. So 9,350 divided by 5,000, that is 1.87. So from here, we need to switch it to log form. Because our base is E, that means that we have E, well, currently we have a number equals E to a power. When we convert that, it becomes the natural log of a number equals the power, because the natural log is a base E. So we're going to have the natural log of 1.87 equals the 0.022t. Before we type that in, we're going to go ahead and divide by the 0.022 and then just save us some time on typing it all in at the same time. So we're going to type this into the calculator. So I start with my fraction button. The LN button is next to the number 4. And so when we type this in, we get about 28.45 years. So it take about 28 and a half years for the account to grow, and that would be our final answer. So if you have any questions, make sure you write them down and you ask for help in class.